Hi guys, today we are going to discuss problem number 1 of Leetcode, that is to sum. In this problem we have been given an array nums and a target, right? And in this problem it is asked to return the index of the pair whose sum is equal to the desired target value. So in this example we have 2 and 7. We add the value of these two, it will give us the target, that is 9, and as an output we have to return their index value. So that is, they are present at 0 and 1th index, so that is what we are returning as an answer. One way to solve this problem is to pick an array element, and with that array element, by keeping that as constant, we traverse across the other part of the array and try to find its counterpart, and where we find it we return both index. But to do that it will require O of n square time complexity, right? And we don't want that. We want an approach somehow which is more optimized. So in this video we are going to see how we can actually reduce this time complexity from O of n square to O of n using HashMap. So let's see how we can actually reduce this time complexity from O of n square to O of n. Basically we will still be iterating over the array one by one, but somehow if we are able to find the counterpart in O of 1 time complexity, then the overall time complexity will reduce to O of 1. Okay, so what does that mean by actually counterpart? So in this example, let's say we have 9 as a target that we want to achieve, and here if we take 2 as a first input, so 2 plus something should give us 9, right? So this something is actually the counterpart of 2. So what this counterpart is actually 9 minus 2 will be the counterpart of 2. So if we can store this in some data structure, which is basically our hash map, so then we will be able to find that counterpart in O of 1 time. So what we will do, one by one, as we traverse over these array elements, we will try to store their counterparts in the hash map. Hence in hash map what we will be storing is the counterparts value. So for 2 the counterpart is 7, so we will store 7, and index value of 2. For 2 the index value is 0 in this case. So let's take a use case different from this one, because this one is not, you will be able to not see the entire picture here. So let's take another example. It will be 2, 11, 15 and then 7, and target would still be 9. So basically we had just rearranged to 7 from here to this position such that we are able to see the hash map better. So one by one we will start picking up the array elements and start populating their counterpart in the hash map. So first we will pick up 2, right? And for 2 we will have its counterpart as 9 minus 2, that is 7. So 7 is its counterpart and it is located at 0. Then we will go to second element, that is 11. We will see is 11 is a counterpart of something or not, right? So no one is looking for 11 as its counterpart. So then what we'll do, we will try to store the counterpart of 11. So 9 minus 11, that is minus 2. So minus 2 at index 1. Then we will pick up 15. We will see if anyone is looking for 15 as its counterpart. So no one is looking for it. So we will store the counterpart of 15, that is 9 minus 15, which is minus 6. Minus 6 at index 2. Then what we will do, we will move to the next array element, that is 7. Here we will see is 7 is a counterpart for anyone or not. So we will find that 7, yes, 7 is actually a counterpart of the element stored at index 0. So the counterpart of 7 is present at index 0. That's what we have stored in the hash map. Hence we will return the final answer. So the final answer that we have to return is the index values. So for 7 the index value is 3, and what we have to return its counterpart value, that is 0. This 0 we will get from the hash map. So this is our answer that we have to return. So guys, let's now move to the coding section, how we can actually code this problem. This is the code for this problem. So basically what we are doing is we are iterating over each of the array elements, and for that array element we are checking is it a counterpart for any other array element, right? And in the meanwhile we are also put a condition to see that we are not referring to the same element itself, because there is a use case like we have a target is equals to 4 and a of I is equals to 2. In this case if we don't put this condition, so its counterpart will be 2, so it might refer to itself. So that's why we have to put this condition such that it don't consider itself as its own counterpart. So we just have to avoid that situation, and we hence put this condition here. If map contains this as a key, right, that means that it is a counterpart of some array element. So in that case we can simply return the answer here itself. But if it is not a counterpart of something, then what we will do, we will store its counterpart such that if this number's counterpart is present next in the array, we are able to find it. So that's why we are storing the counterpart of this current array element here. And then for each of the array element, we will keep on doing the same thing until we find the solution. It is mentioned in the problem that the solution exists, so this condition will definitely be hit. So this returns a statement for Java, otherwise it will throw compile time error. So yeah guys, that's it for this problem. So do like, share and subscribe this video for more upcoming content like this.